Number 3, use the graph below to answer the following questions. 30 milliliters of a weak acid are titrated by 0.2 molar NaOH. So at every point on here, we have 30 milliliters of HA in the flask, and then we're gradually adding hydroxide to it. The net ionic reaction, the weak acid stays together. If it's a strong base, I only write the OH, transfer a hydrogen, and that'll be my net ionic. B, what volume of NaOH was needed to reach the equivalence point? To find the equivalence point, I'm looking for the point of inflection and the steepest point of the graph. If I track that down, we find 20 milliliters of NaOH were needed. That's going to help me because then I know that this is going to represent half equivalence. I need to calculate the original concentration of HA. So remember that at equivalence, my moles of NaOH that we added equal the moles of HA we started with. So at equivalence, we had 20 milliliters based on this of 0.2 molar NaOH, which was given in the problem statement. At this point, we had 30 milliliters of HA. So I can find the moles of NaOH. 0.2 equals moles over 20 milliliters is 0.02 liters, giving me 0.004 moles of OH minus. The definition of equivalence means it's also 0.004 moles of HA that we started with. Now I can calculate the molarity of the HA. 0.004 over 0.03 liters. 0.004 divided by 0.03 gives me 0.13 molar. For D, what volume of NaOH was needed to reach half equivalence? Half of whatever was needed to reach equivalence. Now that I know what the half equivalence point is, I can estimate the pKa value. If I track this over to the side, it hits somewhere around there, which I see as 1, 2, 3, about 4.5. So we're going to say pKa equals 4.5. F, if I want to get the Ka, it's 10 to the negative pKa, which will give me 3.16 times 10 to the negative fifth.